Hi, this is just a short video to show you how to graph y equals sine of x and y equals cosine of x. We'll start with y equals sine of x. So x is the angle in this function. So it's going to use familiar values. We're in degrees right now. And on desmos here, you can change that under the wrench. But we're using 0, 90, 180, familiar angles in degrees as we go around our unit circle on our x-axis. Uh, our y value is the sine of that angle. So if you remember your unit circle lesson, you'll know that a y value on the unit circle is equivalent to the sine of that angle. Reason for that is you think about that y value, in this case 1/2 for a 30-degree angle. Well, that's the height of this opposite side over here. If you imagine a triangle, the hypotenuse would be 1 because it's a unit circle with radius 1. So the sine value is equivalent to the y value. So what we're doing is we're starting for a 0-degree angle, that's the first 0, has a sine value of 0. That's the second 0. So 0 comma 0, the origin is where this function starts. But then from 0, it climbs up through 1/2, square root of 2 over 2, square root of 3 over 2, all the way up to its max at 1. That's this point right here. For a 90-degree angle, we have the biggest sine we'll ever have. It's 1. The y values start to fall as we go down, kind of softly at first, and then steeper as we get closer to 180. The y value is down to 0 at 180. That's this point right here. Notice we're kind of a smooth curve across the top when we went past 90 degrees. That corresponds to this smooth curve at the top of the circle here. So our y value isn't really changing all that rapidly up here because we're mostly moving right to left. But as we get through this part, it's dropping rather steeply. So you can see this part a little steeper as opposed to up top, we were a little flatter. So this thing ends up a soft, smooth, wave-like kind of graph, not sharp corners like an absolute value. As we go through the third quadrant, past 180 and towards 270, we're going to go from a y value of 0 down to our lowest y value, -1, before eventually heading through the fourth quadrant, where the y values are going to climb their way back up to 0. Notice 0 degrees, 360 degrees, they're coterminal. There's a reason these 2 points, this one right here at 0, 0, and this one right here at 360, comma 0, they look a lot alike. They're both the same value, and they're both kind of in the same sort of spot. Everything repeats as we go around and around the unit circle over and over. And this function repeats. It even goes over into the negatives here. Um, Basically, if I go ahead and expand this out, you can see that this function, even if I kind of zoom out a bit, it's just going to continue on and on like a wave forever, just following that same pattern. If we do cosine of x, you'll notice same kind of wave. There's not much of a difference. The only difference is instead of starting at 0, 0 and going up, we start at 1. We start at 0, comma 1, and we fall down first, but otherwise it's the same wave. The reason that it looks so similar is the x values are doing something very similar to the y values. They're only just starting in a different spot. Here we start at 1, and as we move left, our x values get less, okay, until they hit a 0 at 90 degrees. So you can see falling through there. And then our -1 is our very lowest x value way over here to the left. So it's the same kind of thing, except we're going right left instead of up down. So sine and cosine definitely related. In fact, I'll put both of them up here next to each other and you can see the comparison. There's sine of x and there's cosine of x. So they look quite similar. Um, you can see it's the same wave, just one of them sort of shifted over compared to the other one. As far as how you want to use Desmos if you're trying to graph, um, you want to just kind of think about your graph settings. You want an appropriate x-axis and y-axis. If we're in degree mode, we need big numbers because our angles quickly go up to 90, 180, 270, 360. That's why I used a step of 90 to hit all those key points. Um, as far as our y-axis, we don't even really need numbers this big. We could really just go for something like -3 up to 3 would probably be just fine with a step of 1, and that gives us a good view of what we've got going on. But the key thing is the x-axis there. So let me remove this cosine so you can see it a little more clearly. We can do all this same work in radians. Uh, Only difference is we're going to have to change those key values on the x-axis because for radians we don't need such large numbers. In fact, you see it's over those giant numbers, the radians would repeat many times. For radians, well, let's try some small numbers. How about if we go -5 to 10? Ah, this looks better. Um, so clicking on my key values here, 0, 0, pi over 2 comma 1, pi comma 0, 3 pi over 2, uh, and 2 pi. So these are my kind of happy familiar. This pi over 2 is like a 90, and pi is like a 180. 3 pi over 2 is like a 270, and 2 pi is like a 360. Of course, if you want to neaten up your graph even more, one more thing that you can do is just set your step on the radians equal to pi over 2. And it should show you all the key values. And sure enough, there they are. Same thing would work with cosine just fine. So that's kind of the gist of how you would want to graph using Desmos.